This video will cover the topic of linear direct current DC power supply, explaining its components and functionality. Electronic circuits require power. Many devices convert AC input to DC output. DC power supplies offer a stable source, essential for semiconductor circuits and active devices like diodes and transistors. A DC power supply unit converts, regulates, and transmits power, transforming AC into stable DC voltages such as 5 volts, 12 volts, or 48 volts. APC's internal power supply is a great example, providing multiple DC voltages. The block diagram of a DC power supply includes a transformer, rectifier, filter, voltage regulator, and an optional voltage divider, all working in sequence. The first block in the DC power supply is the transformer, which takes the incoming 240 volts, 50 Hz AC voltage. The transformer's function is to step down AC current or voltage to a smaller AC value, making it suitable for devices like lamps, heaters, and specific AC motors. For instance, a transformer with a 10-to-1 turns ratio converts a 240 volts AC input into a 24 volts AC sine wave. The oscilloscope shows the input and step-down output waveforms. Next, the second block is the rectifier. It receives the stepped-down AC voltage from the transformer. The rectifier converts the AC sine wave into a pulsating DC wave using one or multiple diodes. The oscilloscope view shows the AC input and the resulting pulsating DC output. There are three main types of rectifiers: the half-wave rectifier, the center-tap full-wave rectifier, and the bridge rectifier. Following the rectifier, the third block in the DC power supply is the filter, which further refines the output. The filter converts the pulsating DC voltage into a ripple DC voltage, or ideally, a pure DC voltage. While not always perfectly pure, it significantly reduces the pulse, as shown in the waveform. Common types of filters used in DC power supplies include C filter, RC filter, LC filter, and pi filter. The fourth block in the DC power supply is the voltage regulator, which follows the filter stage. The voltage regulator maintains a fixed or constant output voltage. It takes the ripple DC voltage and produces a very smooth, regulated DC output, suitable for all electronic circuits. Voltage regulator circuits typically include Zener diodes, serial transistors, or integrated circuits, ICs, to achieve stable output. The fifth block, an optional component, is the voltage divider, which comes after the voltage regulator. The voltage divider produces a lower voltage from a higher DC voltage. It's used for specific voltage needs within a circuit, and its output can be calculated using a simple resistor formula. In summary, an AC voltage is stepped down by a transformer, converted to pulsating DC by a rectifier, smoothed by a filter, regulated to a fixed voltage, and optionally divided to a specific load voltage. This video covered the importance of DC power supplies, their block diagrams, functions, operations, key circuits and components, and input/output waveforms.